on. We're live. Okay, so what is it? It is it's December 1. It's 66 degrees out there. Wow. 12/1 and 66 degrees. Incredible, huh? Insane, huh? Okay, our objective today is, what we want to do today is we want to apply trigonometry to the unit circle, okay? Here's what we know. Here's what we know. We do know this stuff. Here's what we know. Let me get a different color here. Oh, red will work great. That's all I need is a different color, okay? Here's what we know. Okay? I know that if I were looking at right triangle trig, you know, where sine is the opposite of the hypotenuse, cosine is the tangent, right? But now all of a sudden we've taken that and we've put it on an XY grid. Does that make sense? It's really on an XY grid. So then if I look at this right here, there's my X, my Y axis, right? So when I look at its XY axis, this is the adjacent side, but it's also the X value. Does that make sense? You go out so much, X value. This is the opposite, but it's also the Y value, right? This is the hypotenuse, but if it's a unit circle, it's our radius, right? So we're just going to change those into things like the Y value, the radius, the X value, the radius, the Y value, the X value, okay? Because we put it on the grid, right? So what we know is this. This is an X value, a Y value. So therefore, any point on the grid, and again, I like to show the grid because it's worthwhile. More quickly, let me just show you, hypothetical picture. So, you got a graph here. Let's make that 1, 1, negative 1, negative 1. You got a circle, right? Any triangle in here, any triangle on the grid would have some X and Y value, right? So any point on the circle would have some X and Y value. Okay, I know you're with me. I know you're with me, right? So therefore, and this is no longer a hypotenuse, but it's the radius of the circle. So instead of sine being opposite or the hypotenuse, it's just the Y value over the radius. Does that make sense? Easy. And the cosine, since it's the adjacent over the hypotenuse, it's really just the X value over the radius. And tangent, which is the opposite of the over the adjacent, is really going to be the Y value over the X value, okay? So we've got our unit circle, right? And on our unit circle, we have all of our coordinates. We already put those in here. We have our coordinates, right? Our coordinates are down here as well. So sine of 90. Well, 90 degrees, let's put those in. 90, 180, 27, 270, and 360, right? Sine value is going to be our Y value over our R. We know our R is, unit circle, our R is 1. Okay, I'll stop for a second, okay? Let's back up. Unit circle, unit means radius 1, okay? Everybody agree? Unit circle, radius 1. Okay, sine. The sine value, I'm going to highlight these. So I go to 90 degrees, and I want the Y value, which is a 1. The Y value is 1, right? Every point has some X and Y value. Over the radius, what's the radius of this circle? What's the radius of the circle? So it's sine of 90. Sine 90. Whoa, I'm smarter than a calculator. What do you know? Dang. So are you. Cosine. Well, cosine's the x over the r, so at 90 degrees the x value is 0, right? Or the radius, which is 1. Which is what? Oh, let's check it out. Cosine 90 is 0. Oh, yeah. I'm good, huh?
You're insane.
I'm insane. Now, tangent 90. Now, tangent is, let's see, tangent is the y value over the x value.
So
Undefined. Because we all know you can't divide by 0. What happens? What does Cookie Monster say when you divide by 0?
and you have no friends.
You have no friends, right? Good. So, undefined. Okay, good. Sine of pi. Now, wait a minute. We got to put our pi. So, we do know this is 0 radians. This is pi halves, pi, 3 pi halves, and this is 2 pi, right? I put my radians in there. Same angle, different names. Okay, sine of pi, we know sine is the y value of the r. So if I go to pi, what's the y value of this point? What's the y value of this coordinate? What's the y value of this coordinate?
0.
0. And what's the radius? It is, the radius is 1. Okay, so the answer is just 0. Now, to get that on your calculator, what am I going to have to do? Anybody know? To do this in my calculator, what am I going to have to do? Here's something new. Change my mode. Change my mode, right? So this is the first time I've ever had to do a mode change, right? So, okay, I better change my mode because I'm doing radians now. Okay, so I go my mode. And I go and change it to radians. Okay, and then I go sine of pi. And guess what I get? 0. Cosine of 2 pi, well, cosine is the x value over the radius. 2 pi is right here. What's the x value of this point?
1.
And what's the radius? All right, so I should be able to do that too. Cosine of 2 pi and an answer of 1. Okay, it makes sense because of the position. What's the x value right there? 1, right? Tangent of pi. Well, tangent's the y over the x. Here's my pi, so it's going to be y over x. What's it going to be? 0 over negative 1, which is just 0. You can have 0 on the top. In fact, I can check that. What's tangent of pi? Tangent of pi. Well, you know, 0. We're so smart. Okay, negative pi halves. Where would negative pi halves be on this circle? Right? Yeah, right there. Everybody agree? Pi as a rotation pi halves is this much, and negative pi halves is down here. So we're right there. And sine is the y over the r. What's the y value here? Negative 1 over 1. We get negative 1, right? Cosine of negative pi. Well, if I rotate this way to pi, then I rotate backwards, it puts me in the same spot, right? Cosine is the x over the r, right? What's my x value? Negative 1 over 1, which gives me an answer of negative 1. Tangent of 3 pi, where's that going to be?
540, so it'd be
Yeah. In fact, I'm going to show you. Thank you. I'm going to go, you ready? Backwards. You watching? 1 pi, 2 pi, 3 pi. I'll do it again. We're going backwards. 1 pi, 2 pi, 3 pi puts me right here. Tangent is the y over the x. What's the y value? 0 over negative 1. So my answer is 0. Okay. Thumbs up on that so far? Okay. Now, that was easy. Everybody agree? Okay. Turn the page. Name the quadrants described. Okay. So one of the things I'm going to do is grab your unit circle. Okay. And in quadrant 1, okay, quadrant 1, and we're not going to put all of the coordinates yet. We'll do that tomorrow. Brittany's going to do that. Right, Brittany? So in quadrant 1, you would go over and up. So any point in quadrant 1 would have a positive x and a positive y. You guys agree with that?
Yeah. Just like a graph.
Right. Totally right. So we'd have a positive x and positive y. So any coordinate here is a positive. Positive. That means that the sine value is positive because the sine's the y's. X's are positive, right? In fact, everything's positive. All things are positive in quadrant 1. Now we're going to use our brains. Quadrant 2. Tell me about a point in quadrant 2. Tell me about a point in quadrant 2. What do we know? Yes. Awesome. We agree with that? So what is positive in quadrant 1? The y, which is the sine. You guys agree with that? Cosine's negative. You guys agree with that? Which would make tangent negative also because you'd have a positive with a negative, okay? So we're going to say S positive because you know the sine is positive in quadrant 2, okay? So what do you know about quadrant 3? Negative, negative. Good. So is anything positive in that quadrant?
No.
Wrong. Tangent's positive in that quadrant. Tricked you, didn't I? No, why is tangent positive?
Because it's double negative.
It's double negative, right? It's the y over the x, so it's the negative over the negative. So tangent is positive in quadrant 4. Tricky, huh? Yep. And then what about quadrant 4? Any point in quadrant 4 is what? It's a positive, negative. So what is positive in quadrant 4? Cosine. Very good. So your cosine is positive. So when I was in college, I always liked to do this. We had to memorize. It wasn't too hard to memorize. So we'd say all students take calculus. Well, I remember my teacher in college doing that. I'm going, okay, whatever. Anyway, now, if we know that, let's go back to this question. Okay, name the quadrant. Sine is greater than 0. That means sine would be positive. And cosine is, which means cosine's negative. Which quadrant am I talking about? Am I talking about 1, 2, 3, or 4? Okay. Well, sine isn't positive in 4. 2. 2, right? So the y's are, sine's positive, cosine's negative. Quadrant 2. Okay, now, example 3 is to find the angle. So to find the angle. And we might find more than one angle, which is okay, but come Friday, we're going to talk about why there's 2 angles and how to get only one. Okay, but for right now, so cosine. Now, cosine is the x value, right? Cosine's an x value. So on my unit circle, can you find an x value of negative 1? X value of negative 1.
Fine.
Yeah. So there's only one angle that has an x value of negative 1, and it's pi. So we want to find the angle. So the question is really, now I know it says cosine, but the question really is, what angle has an x value of negative 1? Pi. Does that make sense? A little tricky, huh?
What I'm curious, why wouldn't you put 180 instead? Or just because you're just using the
Oh, such a good question. In radians. But you're right, Lauren, you're completely correct. Both angles are right. Both angles are right, but I just wanted it in terms. So I'm going to go theta equals pi. Or 180, Lauren, or 180. Same answer. Okay, how about B? Tangent is 0.
Could be 2 pi or pi.
Yes. Or even 0, right? Yeah, totally right, yeah. So 0 over 1. 0 over 1 is 0. 0 over negative 1, right? So you could say that theta is either going to be, because you're looking for a y over x answer that equals 0. Kai found it. Theta is either at 0 radians or pi radians or 2 pi radians, right? 3 pi radians. You know, keep going on, right?
Pi.
Oh, yeah. No, we really only want one answer, but we're going to talk about which answer we want eventually, okay? The one that's closest to the origin, okay?
Why would you want that?
Huh?
Just so you don't have to.
Yeah, right. Remember that? We talked about that, right? I mean, Kai's a sprinter. I get it, right? I mean, we don't want to run too far, right? I was a sprinter too, Kai. I get it, right? So, okay. Trick question. Tell me why this is a trick question. Right? So, sine is the y. I can get to here. which is a length of -1. If I wanted to get a length of -2, I'd be off the circle. There's no angle that has a sine value of -2, so it's just undefined. No angle, no angle, so it's really an undefined answer, okay? How am I doing? Good. Okay, now let's look at number 4. Now, all of a sudden, now we're off the unit circle. Now, why do I say that? Why am I off the unit circle? No longer on the unit circle. Yes, keep going. Yes, 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 keep going. What's the radius of this circle?
So big.
Is it bigger than 1?
Yeah.
So it's no longer a unit circle, right? But it's still a circle. We can still do our trig. I think what I should probably find first is the radius. Let's find the radius, okay? Let's find the radius first, okay? Ah, thank you. So if I want to find the radius, how am I going to do that? Right. Good. And you remember your buddy, the old guy, his name starts with a P? Yeah, how about Pythagoras? Do you see a right triangle in there? Not really, but there is a right triangle. Okay. There probably is a right triangle right in here, right? You guys agree?
I'm curious, why wouldn't you go with the other right triangle, like the upside down one?
You can, but we want to get in the habit of going along the horizontal because eventually that's super important, Lauren. So once again, Lauren, you are totally correct. But I want you to get used to making the triangle on the x-axis because that's really going to be important later, okay? So I'm just going to go -3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. C is 5. And I'll wait for you, okay?
What is C?
Great question. Because what, Carly, you couldn't have set I was ready to say what you were asking. A better formula is this, Carly. X squared plus y squared equals r squared is a much better formula than a squared plus b squared equals c squared. Because what is c?
C is
It's the radius, isn't it, Carly? You see now, c is the radius, right? So we can put in our 5 right there. Now, what do we know? Sine of theta. Let me turn the paper. Sine is my y over my r, right? I know my y value. It's 4. And my radius is 5. That's my answer. Okay, cosine of theta. Well, let me see. Cosine is the x over the r, right? So it's the x value over the radius, which would be my -3 over my 5. Okay, what do you think? Not too bad today? All right. It's beautiful outside. You guys want to work outside?
Yeah, sure.
Yeah, let's go outside. I mean, 66 degrees. Right?